For our next example of combinations, let's suppose that we have 8 people in a volunteer committee, and we need 3 people to volunteer at the next event. Now, any 3 people can serve for this committee. There's not a hierarchy that we're worried about. You can just pick any 3 people. So we're going to take our total number of people, 8 factorial in our numerator, divided by 3 factorial, times the difference, 8 minus 3, which is 5 factorial. So the number of possibilities for this guy would be 8 choose 3. So 8 factorial divided by 5 factorial times 3 factorial, which is 56. Again, don't forget, order matters on permutations, but order doesn't matter on combinations. Okay, so let's take a look at this. Now we're going to put all this information together. What's the probability of a defective light bulb? A box contains 20 light bulbs, exactly 4 of which are defective. So we already know that 4 of the light bulbs in the box are defective. If I take 5 light bulbs out of the box without looking, just randomly pick 5, what is the probability that exactly 2 of the light bulbs are defective? So I put a picture on here so you can see the slots that we can fill in. So we're choosing 5 light bulbs. So here each light bulb represents one of those 5. Now I know that 2 of them are defective. So the probability of that 2 being defective, So the probability of choosing 5 light bulbs out of the box is 20 choose 5. There are 20 choose 5 different ways of choosing these light bulbs. If exactly 2 are defective and I choose 2 of the 4 defective light bulbs, that can be done as 4 choose 2. So there are 4 that I know are defective. I happen to choose 2 of them. That means the other 3 that I chose came from the non-defective light bulbs, which is 16 choose 3. If I multiply those together, I can get the probability of choosing both of them. But then I also have to divide that by the total probability of choosing those 5. So following the same formula, but now this time I have multiple different types of items. Okay, so my outcome is still on the top out of my total outcomes in the denominator. The formula looks a little crazy because I have all the math here, but you can put that right in your calculator, right in your Excel spreadsheet, and it'll work that for you. It should get 70 out of 303. Total outcomes are going to be this outcome where I have 2 that are defective and 3 that are not. So I have a 21.7% chance of getting this set of light bulbs. Notice that I changed that decimal into a percentage by moving 2 decimal spaces. What's the probability of 4 of a kind? Ooh, okay. So suppose that we have 5 cards from a deck. What's the probability that 4 of the cards are the same? Okay, so we have to think about this. There are 13 ways of drawing the same exact cards, right? So you can draw 4 2s, 4 4s, 4 jacks, 4 kings, 4 aces, right? There are 13 different ways of this happening. After drawing 4 of a kind, then you have 48, because 52 minus 4 is 48 cards left, for which you can draw that 5th card. So, we would do 13 times 48 to get our possible number of outcomes, 624 outcomes. So this is the fundamental counting theorem, right? Now, we have to divide that by our total sample size, which would be 52 choose 5 cards, which is 2,598,960 possible ways to choose 5 cards in a hand. if order doesn't matter, right? And order doesn't matter in this case because I can shuffle my cards and I still have 4 of a kind, even though I have them in different order. So the probability of 4 of a kind would then, we can take that 624, divide it by 52, choose 5, to give us 1 out of 4,165 chance to get 4 of a kind. So that's a very, very small probability. What is happening? That's the last slide. In our book, in this section, section 5, there are a slew of different examples. So before you get into your homework, I would go through there and look at the different ways that you can use all of these counting theories to find different probabilities. Notice that in each one of them, we put the possible number of outcomes divided by the total number of outcomes. Even if it got a little weird in some cases, like in this light bulb case, the possible number of outcomes for this one and this one were multiplied together because it was an AND situation. It's in our numerator because it's the possible number of outcomes, and then the denominator is the total ways that you can choose 5 cards, okay? So that's the main theme for probability. If you need some more examples for videos, I have a couple of people who are really good at doing examples for this, so just reach out to me and I can send you some more videos.